In this video, we're going to talk about multiplicity of a zero. So first, let's go ahead and find the zeros of this function. So to find a zero, you set the function equal to 0, and then you solve for x. So first thing I'm going to do is factor. So I'm going to pull out an x squared. I'll be left with x squared minus 4x minus 5. Okay, and then I'm going to see, can I factor this easily? Can I think of two numbers when you multiply them together you get -5, but then when you add them together you get -4? That'd be -5 and +1. -5 and +1. Okay, so now I've factored this. I'm trying to find the x's for which this equation will be, will equal 0. The right-hand side will equal 0. So if x squared equals 0, the whole equation, the whole right-hand side will equal 0. If x minus 5 equals 0, the whole right-hand side will equal 0. Or if x plus 1 equals 0. So let's go ahead and solve each of these. So if I were to take the square root, I would just get 0 there. X equals 5, add 5 to both sides, and x equals -1. Okay, these are my zeros. So the next part of the question asks us to find the multiplicity of each of these zeros. So to understand multiplicity, I'm going to rewrite this. Instead of writing x squared, I'm going to write x minus 5, and x plus 1. Why did I write it like that? Well, if this x equals 0, the whole thing goes to 0. If this x equals 0, the whole thing goes to 0. Okay? And then we still have x equals 5 and x equals -1. All right, and those only show up once. All right, so, what is the multiplicity? So what are we saying? We're saying the multiplicity of x equals 0 is 2, because it shows up twice, right? So let me write that. The 0, x equals 0, okay, has multiplicity 2, okay? And then the 0, x equals 5, has multiplicity 1, because it only shows up once. And then the 0, x equals -1, has multiplicity of also having just 1. All right, knowing the multiplicity is it's important so that we can kind of begin to understand something about our graph. So in the next slide, I'm going to kind of show how you would graph this by using this information about multiplicity. Okay, so this is a recap of everything on the previous slide. Here's the function f, and then here's what we know about the multiplicities. All right, so I'm going to go ahead and try to graph this. All right, so first thing, before we talk about multiplicity, we know something about the end behavior because we've watched the previous videos. We understand end behavior, so we know that if we were going to use the leading term test, leading term here is x to the 4th. Okay, and x to the 4th, and the leading coefficient is just +1. So we know the end behavior is going to be going up as x goes to -infinity, so y will be going high, and then also as x goes to +infinity, it will be going up. Remember, it would be something like this. Something unknown is going to be happening in the middle, but towards the end, we know it'll be going up like that. So I'm just going to, I like to just draw my end behaviors kind of like that. Okay, all right. Then I have 3 zeros, and zeros are where, the x-intercepts are. So I have an x-intercept at 0, and then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I have a 0 there. And at -1, I have a 0 there. All right, so now I know now I have something about the multiplicity. Now how does that help me? Well, when the multiplicity is even, so such as 2, so even when it is even, the graph touches but does not cross the x-axis. So graph does not cross the x-axis. All right, and then when multiplicity is odd, such as 1, okay, then the graph does cross. The graph crosses the x-axis. All right, so we're going to cross the x-axis at 1, at -1, and we're going to cross the x-axis at 5. But at 0, we're just going to touch. So it's going to look something like this. All right, we don't know how deep it goes, but we know that the graph looks something like that. All right, I'm not labeling my y-axis because we actually didn't find any y points. I'm just saying that it's going to do something down here. It's going to turn around, and then it's going to turn around at 0. It's going to do something else down here. We don't know what, but then it turns around and goes back up. Oh, talking about turning around, these points where you turn around, okay, also it turns around there actually too. These points are called turning points, okay? So these are called turning points. And, turning points are, the local max and mins, the local or relative min and max, right? Something about turning points, you should always know that, if you were to graph a polynomial, there should be no more than n-1 turning points, okay? So there should be no more than n-1 turning points. So if you did a graph and you could check to make sure that you didn't make a mistake, because if you have more than n-1 turning points, then you've made a mistake. So in this case, n equals 4, right? This is a 4th degree polynomial, right? So this is a 4th degree polynomial. So I should have no more than 3 turning points. And you see I have marked my turning points in red, and I have exactly 3. So I know that, I'm on the right track here. To find exactly where the turning points occur, you could use a calculator. You could use some sort of graphing tool. But we're not going to talk about it in this class, how to find the exact points that they occur at. When n equals 2, or when this is a quadratic function, we do know how to find the turning point. It's the vertex, and we've already discussed how to find vertex in previous discussions.